This section is on simplifying expressions. So let's begin by explaining to you what's an expression. An expression is made up of terms that are separated by plus or minus. So take for example, if I gave you an expression made up of 3x squared y minus 5xy cubed minus 7xy squared. So if this was the question, how many terms will there be? So understand that 3x squared y, they're all separated by multiplication, so that doesn't count. The very first separator is right here. So that whole piece is considered to be one term. So after the separation that is made with a minus, the next one is called another term. And then there's another separation right here. So the next one is another term. Okay, so there are altogether 3 terms in this expression. So now that you understand what's term, the next thing is what is considered to be the coefficient. So this is how we ask you the question. What is the coefficient? What is the coefficient of, say, x squared y? So when we say coefficient, we are referring to the number part. So notice that every term is made up of 2 pieces. One is the variable part, the one that carries the letters, and then you have the number portion. So since there's 3 terms, I have to tell you which term I'm looking at. So look for the one that has x squared and has y. So 2 x's and 1 y. So if you look carefully, I'm referring to the very first term right here. Okay? And so giving you the letters is just to pinpoint which term I'm looking at. Now how do you know what I'm asking? That's when I'm asking you this word, coefficient. Then what am I referring to? The coefficient is just a number portion. So the answer to this question is the coefficient is 3. Now if I want to ask you for the second term, I would say what is the coefficient of, let's not try the second term, let's try the third one, okay? xy squared. So what is the coefficient of xy squared? So when you look at xy squared, at one glance it looks like it's the first term, but look carefully, we want 1x and 2 y's. Okay, so we are now referring to the third one. So if you look at the third one, you notice there's a number there, and watch out, the answer to this question is not just the 7, because observe, there is a minus in front of the 7, so that belongs to the 7 too. Okay, so watch out for that. If there is a sign in front of the number, it really belongs to the number. So the answer to this question is it's negative 7. So now that you understand what's coefficient, what's the next thing that we can ask you? The next question we would like to ask you is what are considered to be like terms. So for you to be considered to be like terms, you must have the same variables raised to exactly the same exponents. So if you look at the previous example, it seems like every term has x and y's in it, but then they have different number of x's and different number of y's. So if you look at the first one, there is 2 x's and 1 y. The second term has 1x and 3 y's, so that's different. And the third one has 1x and 2 y's. Okay, so although they all have x and y's, but they have different amount of it. So in this case, they are considered unlike terms. So these are unlike terms. Okay, so like terms, they must have not only the same variables, they must be raised to exactly the same exponents. That's important. So take for example, if I have 3x squared y minus, say, 5yx squared. So the first thing that you notice is, hey, there are 2 terms, okay, because there's a separation. But if you look closely, look at the variable portion. The first term has 2 x's and 1 y, okay, and in multiplication, you know, is commutative. Looking at the second term, can you see it's also 1y and 2x's? So if you look carefully, these are like terms. So these are what we call like terms. Okay, so although it looks different, but really they're the same because multiplication is commutative. So when they are like terms, what we can do is we can simplify. Okay, so when we say simplify, what we really mean is to combine like terms. So the method to combine like terms is you will add or subtract the coefficient portion, that means the number portion, but very important, you must keep the variables unchanged. This is important. Meaning, the variable portion is to identify that they are the same kind, okay, as in they are the same family. So what you do is you're going to combine the coefficients. Remember, the first term, the coefficient is 3. And for the second term, the coefficient is really -5. So you have to think, what is 3 minus 5? So the answer is -2. But don't forget to keep the variables unchanged. So at this point, you have a choice. Would you like to write it as x squared y? Or would you like to write it as yx squared? Okay, and the most common way is to follow the alphabet. Okay, so go by alphabetical order. So x comes before y, so that's why the answer is normally written as x squared y instead of yx squared. Okay, so we go with the alphabet order. Okay, so this is what we mean by combine like terms. So we can make it more challenging, so the expression will be a lot bigger, so let's try that. So can you simplify negative p squared plus q plus 7p minus 9q squared minus 10p, say, plus p squared. So that's a big mess, but how many terms is that? So there's one term right here, 2, 3, 4, 5, and 6. There are 6 terms. Okay, so what you do is you look across. So right now I have a p squared. I'm going down the line. Do I see another p squared around? So down there, there is a p squared. So observe, what I have here is when you see a negative, it really means -1. So I have a -1 and I have a +1. So what happens when you go -1 plus 1? -1 plus 1 is 0. 0p squared. But if it's 0p squared, you don't write it. Okay, so that's why we just cancel. Alright, moving on. Next one is q. Okay, so I have q right here. Looking down the line, I don't have any more q. So that's it. You're alone. Now I'm at p. So when I look at the p, the coefficient is +7. And the coefficient of that p down there, his coefficient is -10. So 7 with -10 makes it -3. But don't forget to keep the variable. And so I'm done with all these, so what's left is just that, which is -9q squared, and he's alone. And that will be my answer. Okay, so this is what we mean by simplify an expression. So sometimes we do confuse you a little bit because we may bring in parentheses. So take for example, can you simplify, okay, can you simplify 5y minus 2 parentheses y minus 3x, close parentheses, plus 2 parentheses 7x minus y. So what you're going to have to do is to remove parentheses first, then combine like terms. Okay, so you cannot really combine them when they're still in their own little parentheses. So you're going to have to remove the parentheses first. So let's see if you remember how to do this. What's in front of this parentheses is a -2. Remember, the sign belongs to the number that comes after it. So the 2 has a minus in front of it. So what you're really distributing is -2. So -2 times y and -2 times -3x. Okay, let's try. So 5y is alone, so 5y. -2 with y is -2y. -2 times -3x. So that will make it positive 6x. Then that's it. The parentheses ended, right? So now we have another parentheses back there. and in front of it is a positive 2. So again, I need to multiply and distribute in there. So 2 times 7x will make it a 14x, and 2 with a negative y is negative 2y. Okay, so there you have it. So all the parentheses are removed. So once it's removed, I can now look for who is the like terms. Okay, so there's a y right here, there's a y right here, and down the line there's one more y. So what is 5 with minus 2 with minus 2? So 5 minus 2 is 3, and 3 minus 2 is 1. So do I write 1y? The answer is no. I just write it as y, because it's understood when you do not see a number, it means 1. Moving on, there's a 6x and there's a 14x. So 6 plus 14, that makes it 20x, and it's positive, so I have to put a plus, and that's it. Everybody's taken care of, and that will be the answer. So the next thing that you need to know in this section is that you need to know how to convert phrases to expressions. Okay, so how would you do that? So you have phrases and you have expressions, so you need to know how to convert. So what are the common phrases that we use? For example, we would use things like sum of A and B. This is something we talked about in the earlier section. Okay, so let's see if you remember. Sum of A and B. So that would mean when you say sum, you're talking about addition. So that's A and B. So in this section, we don't mention that. Instead, what do we say? We say sum of a number and 5. So you understand that there is an unknown, and the unknown is a number. So since it was not specified what letter you need to use, the common letter we choose is X. So basically we're letting X be the number. Okay, so sum means addition, number, we're going to use X to represent, and so followed by 5. So what other ways can we talk about? We can say, instead of using the word sum, I could say a number increased by 12. Okay, so when you see a number, it means X. Increased by is just another way of saying plus, so that will be a number plus 12. So enough of plus. How about minus? What word would I use for minus? So if you look at the previous section, I had introduced the word difference. So difference of A and B, that means it's A minus B, right? So here we could use other words like, for example, a number decreased by. So instead of increase, we say decrease. Decreased by 11. So a number is X. So X decreased by as in minus, and minus 11. So how can we make the question harder? Okay, how about we use something like twice the sum of a number and 4. So you understand that when you see the word sum, it means addition. Okay, the only thing is what I'm trying to do here is to double the sum, so twice the sum. So what I need to do is I have an addition involved, but the result, which is what we call the sum, I eventually wish to multiply by 2. Okay, so how come before we never did that? So let's try that. Okay, so twice the sum, so twice of the parentheses with a plus in there, and you have the number, and you have 4. So how do you think I would say it if I only want to multiply x by 2 and not in a parentheses? Then I will have to say something else, right? So let's try that. How do you think I would have to say it if I want to say 2x minus 3? How do you think I would tell you? Okay, so this is the expression. How would I say it as a phrase? So observe that I'm multiplying the number by 2. So instead of saying twice the difference, I'll have to say twice the number. Right? So twice the number, so that means I'm multiplying the number by 2. And there's a subtraction, so I'm going to have to say decreased by and decreased by 3. Okay, so that's one way to say it. So we're going to talk more about this, but think about things like ratio. Okay, so ratio of A and B really just means A divided by B. It's really no different from quotient. So another way of saying that is really your quotient. We also say 5 times the difference of a number and 1. So think carefully. What's 5 times the difference? So 5 times, you understand 5 times means 5 times. 5 times what? 5 times the difference. So that means I have to use a parentheses. And I think you can guess what's in the parentheses. What does difference mean? Subtract, right? So that creates 2 spots, one before and one after. And that's when you put the number and you put 1. Now, I need you to compare this with 5 times the number less 1. So this time, I still say 5 times, right? 5 times. Except what is it I'm multiplying by? I'm multiplying by the number. So it's 5 times x. Less, so minus 1. So I think it's a good place to remind you, what happens if I say 5 times the number less than 1? So what if I use this word? Do you remember? So we talked about this in the earlier section. The minute you see 2 words, then and from, don't forget to reverse the order. So how would I write this? 5 times the number means 5x. Less means subtract, but the minute you see this, you don't put the subtraction behind the 5x, you put it in front of the 5x. And the 1 will be going in front of it. So in that sense, the order is switched. Okay, so I need you to think a little more about this, but this is what we'll be talking about in this section.